I know that those of you who are not botanists, nor ecologists, nor geologists will probably need me to explain the title at some point, and I'll get to that, but give me a minute. So when I came to COA, I knew that I wanted to be a botanist. My parents are back there in the audience, you can ask them. I've been saying, I want to be a botanist since just as long as I can remember. So starting off at COA, I got involved with botany classes, research that my advisor, Nishi Rajakaruna, does in Maine. That first summer, I was out in California doing post-fire vegetation monitoring for the University of California at Davis. The next summer, I was in Chicago at the Field Museum doing molecular genetic studies of lichens. I've also done some work here in Maine. There's an estuary about an hour down the coast with a lot of heavy metal pollution, and we've been documenting metal uptake in the seaweeds of that environment. And I've also spent an inordinate number of hours measuring beans for Suzanne Morse. And during that time, I've also been working on this particular kind of rock called serpentinite. And this will be the most technical part of the presentation. So serpentinite is a rock that's derived from the Earth's mantle rather than from the Earth's crust. And because of that, its chemistry is a little different than most rocks that plants encounter. And so the soils that are produced by serpentinite rocks, which we call serpentine soils, can often be a stressful environment for plants. And I've visited these soils and done research on these soils in places like California, South Africa, where Nishi and I were in February, and right here in Maine, in Little Deer Isle. And when it came time for me to do my senior project, I thought back to the very first meeting I ever had with Nishi when he gave me this paper to read, which was a review article of what we knew about serpentine geoecology in northeastern North America. And when I read that paper, I remembered that there had not been anything about my home state of Massachusetts in the literature review. So I like digging, so I found some geologic maps and saw that this rock type actually does occur in Massachusetts, just that the state, no one had really done any comprehensive work on it. That was in the back of my head for 3 years or so, and then when it came time to plan out my senior project, I decided that's what I would do. One thing I've been really happy with about this project is that I've had a lot of ownership of the project from start to finish. So some of the other projects I talked about, research that someone else had written the grant for, or someone else had developed the project, and I had been collecting the data, analyzing the data. But with this project, from start to finish, it was really something that I was deeply invested in. I dug into the geologic maps, located sites. I went into tax records to figure out who owned prospective sites, wrote to all of them, negotiated with landowners about permission to do research there. I applied for grant funding from a variety of sources who very graciously funded this project. And then last summer, I was out in the field in western Massachusetts. If you know Massachusetts at all, sort of a transect from North Adams down to Westfield. Now, if you'll remember from an earlier slide, serpentine sites around the world typically have this very barren, stunted appearance. There's not much woody vegetation, stunted trees, sort of a sparse herbaceous layer. And when I proposed my project, the hypotheses I listed were predicated on this assumption that serpentine habitats have this barren appearance. And then when I got out into the field in Massachusetts, I realized that that really wasn't the case. And my very first day of field work, I knew I had my GPS in hand. I knew of the coordinates of where the outcrop probably was. And I knew that it was between schist on one side and amphibolite on the other. So I was walking back and forth across this geologic contact, rock hammer in hand, knocking pieces off of rocks as I went. And then at one point I got up to this outcrop, and I took a swing at it, and I got this dark green rock that came off, which is serpentinite. That's how you recognize it, this dark green ultramafic rock, very high in iron and magnesium. Also some nickel and chromium as well. And so I was shocked. I'd never seen a closed canopy forest serpentine outcrop like this. And over the course of the next summer, my research shifted from documenting what was distinctive about this habitat in Massachusetts to figuring out why is this habitat not distinctive in Massachusetts. And what I found out was that despite soil chemistry, which did reflect the parent materials, the soil had elevated nickel, had higher magnesium. Despite that soil chemistry, you had a typical hemlock beech forest with the normal understory herbs for that area. There's nothing really distinctive about it. The one somewhat distinctive habitat within these outcrops were cliff faces. So on cliff faces of the serpentinite bedrock, you did have some mosses and some ferns that were characteristic species that you didn't really see on other rock types. And there were some lichens that were totally absent on outcrops of serpentinite, but abundant on cliff faces of other lithologies. So the serpentine cliff faces are a little bit of a distinctive habitat, but the outcrops themselves really are not. And what I suspect is that in other areas of northeastern North America, whether it's barrens in Maryland and Pennsylvania that have periodic fires, or our outcrop down in Little Deer Isle, which is a rock dome without much soil, not much water holding capacity, or alpine areas of Quebec and Newfoundland, where you have cold stress and drought stress. On the sites I've worked on in Western Massachusetts, there really aren't additional environmental stressors. And I suspect that that's why these sites don't behave as you typically assume a serpentinite habitat will behave, because despite the soil chemistry, there aren't these other compounding stressors. And that's what I reported back to the state of Massachusetts. So before I did this project, the state said that, well, we have this rock in the state. Elsewhere in Vermont, Maryland, Maine, it's a distinct habitat, so it's probably a unique natural community in Massachusetts. And what I reported back to them is, no, not really. And Matt Messina, who presented before me, I think he has the best description that I've heard of this. He says, I'm the botany equivalent of the guy who decided Pluto wasn't a planet. So actually, I got an email a couple of weeks ago from the state of Massachusetts, the Natural Heritage Program, and they have removed this habitat from their classification of natural communities in Massachusetts, which is not at all what I set out to do, but it is what the science reflects. So there's so many people who contributed to this project, either encouraging me, teaching me, funding me, allowing me to access their land. And after this, in a few days, I'm going to be driving down to Texas to take a job working for the state of Colorado on a contract for the National Park Service in Texas. You follow that? And part of the reason I have that job is because I have this experience working on natural community classification and habitat evaluation. So with that, I'll open it up for questions.